Hey guys, welcome. This is our 7.4 video. So we got a couple of vocab to go over and then some problems. Let's get started. Okay. First, alright, make sure you write down, there's going to be 3 take notes. Please write down everything you see. Okay? So everything in here, make sure you write it down. That was really well done. Alright, well first, what we're basically looking at is we're going to be talking about dividing a triangle up into 2 similar triangles. So if we actually create an altitude, so we have the altitude coming right down here, CD, from our right triangle, we can actually divide the triangle into 2 similar triangles. So this little altitude right here creates ADC, and then it creates this other half is CDB, and they're all similar to the original triangle ABC. So we're going to kind of play with this idea of taking the altitude of a right triangle, breaking it up into basically 3 different similar triangles. Let's go ahead and take a look at what we can actually do with that. So what we can do with that is our first corollary. Corollary is just something that's based off of another theorem that we have, and it says the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the length of the segments of the hypotenuse. So basically we can make a little setup. The word geometric mean just means we're going to basically set up a proportion here for our purposes. But as you can see here, what we're going to do is we're going to take the fact that we have 2 smaller similar triangles, and we're just setting the sides proportion to each other. So we've done this before. This isn't anything crazy. So as you can see, we would do 2 to 4. So basically like AD here would be 2 to 4 would be CD. And then we want to go ahead and match what matches with 2, what's the corresponding side to 2, and that would be 8. 4 on this one right here, but we want to put it on the bottom. We're going to put the similar thing right down that middle. Okay, so we go 2 to 4, and that's just going to match to 4 to 8. We can set this up in this way. We can also set it up in another way. And that's when we're taking a look, and we don't know the altitude, but we know one of the sides here, and the side's going to get double counted. So, for example, on the big triangle we have 4 to 2, whereas the smaller triangle we have 2 to 1. So we're going to mess around with these proportions and do a couple problems. So let's go ahead and take a look at our first problem. Okay, so our first problem here, again, make sure you write down what it says and the picture. But basically we want to say what similarity statements can we write relating the 3 triangles in our diagram. I've been having trouble with my pen, so it's kind of laggy, so I'm going to try this. We'll see what happens. It might be really bad, it might be okay. Let's go ahead and see. So far it's looking pretty laggy. I can't really do anything yet. I'm over it, not doing the pen. Okay, so anyhow, let's see if I can get it with my just normal pen. So here we go. So here we can look at one of the triangles is right here. Whoop, whoop, whoop. So that's one of our similar triangles. And then we have the little guy over here. Whoop, whoop, whoop. Well, it's really badly drawn because I don't have my pen. And then we have the last one, which is the large triangle, and that's the outer one. Okay, so you don't have to highlight that, but that's essentially what we want to do. We want to go ahead and take a look at this figure and try and pull it apart, and that's really going to be helpful when we want to set up actually our proportions on the second part. So here we're just looking at which ones are the similar ones, and so we can see here as we kind of fast forward real quick, we can draw out the triangle. So there's the main triangle. So draw that, and then we're going to take the next largest triangle, and we got to go ahead and rotate it so it's in the same thing. So this is going to kind of flip down. So here it goes, and we're just going to kind of switch it around, and then we're going to reflect it over, and there we go. Now it's in the right location. So here we can see YW and XY are corresponding to each other, and then we got to take the last piece, this little guy, bring him down. So he's going to do a little rotation. So this really helps with, we did this kind of reflection stuff before. He rotates, and we're going to reflect him. And now we have all of our pieces. So we can clearly see which ones match up with which. This is not how it looked originally, but if you need to visually write this out, this might really help with our next couple problems. So let's go ahead and look at our next problem. Alright, so here's our second problem that we're looking at. So make sure you write down what are the values of x and y, and here's our picture. So this is exactly what we're going to see on the test. So when we're looking at this problem, we want to go ahead and set up some proportions, and we want to align things that are going to match with one another. So this can kind of be tricky. So the first thing we want to do is we would like to label some points. So we're going to go ahead and let's go ahead and get some points in here. So just fast forward, there we go. So now we have some points that we can actually look at and say, all right, what do we got? So we're going to use our second corollary. This is one of the two that we wrote down, and to go ahead and solve for x. So essentially what we're going to do is we're going to go ahead and take a look at one of our segments, AB here, this full segment, and compare it to x. This is part of the same triangle. And then we're going to take a look at x and how it corresponds to 4. And if you actually think about it, and I'm going to go ahead and fast forward this. Okay, so we're going to leave right there. So everything you see, please write this right here. So AB, if you look at AB on the large triangle, it is the hypotenuse. So it is the hypotenuse of the large triangle. That corresponds to AC, which is the hypotenuse of the small triangle. So we're setting up a ratio here. So we have AB is the long piece, AB, and then AC is the short piece of the large triangle, and then AC is the hypotenuse of the baby triangle. So we got 3 sides of the triangle, big, medium, and large. And so AC is the small triangle, and then we want to do hypotenuse over short leg, and 4 is our shorter leg here, so we're going to put over 4. So we just got to go ahead and write in our proportion by filling it in. So go ahead and do that. We substitute our values in. So AB is going to be 4 plus 12, and then we can go ahead and solve, and then we take the square root. Now, normally square root of 64, we could get 8 or negative 8. We're going to just keep a positive 8 only because distance can't be negative. Okay, so there we are. Nice and simple. We have that one. Now we want to go ahead and find the next one. So we're going to go ahead and carry on. Now we're going to write another proportion. Okay, now when we're looking at this one, we want to find y here, so we need to include y. So if we look at AD right here, which is the short leg, and CD, which is the long leg. Remember, we have a short leg, a long leg, and then we have a hypotenuse in a right triangle. So AD, we're doing short leg to long leg, and then we're going to take a look at the medium-sized triangle, and we're going to do short leg CD to long leg. And we always want on that this diagonal, this positive diagonal here, we want the same value. And so we can go ahead and get that value. We plug things in and use our cross products, and we get y squared equals 48, take square root of it, and we're not going to get a perfect answer here, so we're going to be left with 4 rad 3. Okay, so that is what we end up with for our final answer. And I will warn you this as a part of your bonus. You watched the video over the weekend. This question will